Module 9 is looking at systems of linear equations. So what a system of linear equation is it consists of two or more linear equations that have the same variables. So in Algebra 1, we are just going to look at two linear equations at once, and both of those will have two variables. So we'll have an x and a y. The solution of a system is an ordered pair written in the form x comma y that makes all equations in the system true. So in other words, the system is where do the two lines cross? So if we were to graph them, what is the ordered pair where they cross? So for the beginning part, we're just going to look at one ordered pair, and then we're going to look at different types of systems that have other sorts of answers and solutions. So for example 1, we're going to solve the system of linear equations by graphing. Check your answer. So we have two different options here on how to graph. Option number 1 is to solve both equations for y. So I'm just going to copy them down here. And we're just going to rearrange it. So this one has a minus x, so we're going to add x to both sides. So we have y equals 3 plus x. And then if I want it in true mx plus b form, I'm going to flip that around. That x is positive, and so is that 3. So it would be x plus 3. And then I have to do the same thing here. We're going to move that 2x to the other side. And if I wanted to flip it around, that 2x is negative. There's a minus sign in front of it, so we're going to put negative 2x. And then that 6 is positive, so we're going to put plus 6. So now those are both solved for y, and we can graph using the y-intercept and the slope. Or if I wanted to find the x and y-intercepts, remember, if I want the x-intercept, I'm plugging 0 in for y. If I want the y-intercept, I'm plugging 0 in for x. So in the first equation of negative x plus y equals 3, I'm going to find the x-intercept first, so that y is going to become a 0. So I would be left with negative x equals 3. And I don't want negative x, I want positive x. So I am going to divide by negative 1, and that would leave me with x is negative 3. And then I have to turn around and do the same thing for the y-intercept. I'm going to put a 0 in for x. So I'm going to be left with y equals 3. And then I have to do the same thing for the other equation. If I put a 0 in for y, I'm going to be left with 2x equals 6 and divide both sides by 2, so x would be 3. And then if I put a 0 in for x, we would just have y equals 6 left, because 2 times 0 is 0, so that would be gone. And now to graph, oh, my graph went all the way down to the other page. We have x plus 3 here, so y-intercept is positive 3, so a dot at 3. And the slope, remember, is the m, which is the coefficient in front of the x. And in this case, it would be 1, so I would go up 1 and over 1. So to get a straight line and good points, I'm going to do this in both directions. So there's that line. And then the other line, negative 2x plus 6, our y-intercept is 6, and our slope is negative 2, so I would have to come down 2 and over 1. Down 2 over 1, and so on. But you can see they're already going to cross there, and that ordered pair is 1, 4. So that would be my answer. Now, if I wanted to graph using the y-intercepts, I could put, for this line, x at negative 3, and y is at positive 3, and then I could connect those two to make a line, which is the same line that we graphed. It's just a different way of doing this. And then I would have to graph these intercepts at x is positive 3, and y is at 6. And then I would have those two lines, and then I would find the ordered pair where they cross. So two different ways to do it. Whichever one is easiest for you works for me as well. All right, now special systems. This is where we can have different solutions here. So a consistent system has at least one solution. It can have more, but it has at least one. An independent system has exactly one. So that's what we just graphed. It had only one solution. They crossed at one point. A dependent system has infinitely many solutions. And if you look down here, right here is infinitely many. That means that both of the linear equations are the exact same. When they're presented to you, they may look different, but when you rearrange them for y equals, or when you find their y-intercepts and x-intercepts, they're going to be the exact same line. So that's why they have infinitely many solutions, because they cross at every single point on that line, and lines go on forever in both directions. So we can't possibly pick out the points where they cross. And then an inconsistent system, it has no solution, and that is right here where you have parallel lines. So they're never going to cross, no matter how far we extend our graph out. They're never going to cross because they're parallel. All right, so use the graph to solve the system of linear equations, and then classify each system. So when you see that word classify, that means we have to go back up here and use our vocab words. So I am going to solve both equations for y. So I'm going to minus x from both sides, and I would have negative x and a positive 7. And then this one, I'm going to subtract 2x from both sides. And then I have to divide both sides by 2. So I'm going to do negative 2 over 2 first, which would be a negative 1x, and then 6 over 2 would be a positive 3. So I just switched the order there before I wrote them. Okay, so our slope here, our y-intercept for this first one is a positive 3. Our slope is negative 1, so I'm going to go down 1 over 1. And my graph got cut off when I opened this in Kami, so we're going to see how this works out for us here. So that's that line. And this line has a y-intercept of not positive 6. Up one more, positive 7, and a slope of negative 1. So I'm going to come down 1 over 1, down 1 over 1. So as you can tell, these lines are going to be parallel, so there's going to be no solution. And then when we go back up here, no solution is an inconsistent system. So we can write inconsistent. All right, and then for our last example, we're going to do the same thing. Solve for y here. And again, you can find the intercepts if that's easier for you. And then divide both sides by 2. And negative 2 divided by 2 is going to be a negative 1x, and 6 divided by 2 is going to be a positive 3. And then we're going to minus x on both sides here. So y equals a negative x and a positive 3. So if we look here, really don't have to graph this, because what do you notice? They're the exact same line. So quickly, y-intercept is at positive 3, and slope is negative 1, so I would come down 1 over 1. Both lines would be right there. So this has infinitely many solutions. Oops. And then when we go back up and take a look at our vocab words, A consistent system has at least one solution. Well, this definitely has at least one, so I'm going to add consistent to our list. And then an independent has exactly one. This does not have exactly one. And a dependent system has infinitely many solutions. So this would be a dependent as well. So sometimes there's only one classification and sometimes there's more. So we got to look through all of them.